A comet that wasn't supposed to be like this. Imagine a visitor from deep space who came to us not from the far outskirts of the solar system, but from another star system altogether. It has pierced the vicinity of Jupiter, flew close to Mars, and is now retreating into interstellar darkness. And we only have one chance to figure out what it is while it's still visible. This guest's name is 3I Atlas. This is only the third confirmed interstellar object in history that we have seen in our neighborhood. But the more scientists observe it, the more oddities surface. In the early stages, it seemed like just a fairly modest interstellar comet, but recent weeks have brought some new, very unusual results. It was the first time a radio signal was caught related to its chemistry. Its tail began to change and stretch out, and the polarization of the light from its dust is not at all like anything we've seen before. In parallel, an almost political story erupted. A Chinese probe showed images of a comet near Mars before NASA, and a whole discussion began around it. To understand why there is so much noise around 3I Atlas, let's quickly remember what kind of object it is. Comet 3I Atlas was discovered in July 2025 using the Atlas telescope system. It quickly became clear that its orbit was not closed, but hyperbolic, meaning it was not bound by the sun's gravity and just flew by. The speed on infinity, it has about 58 kilometers per second, which is noticeably higher than that of ordinary comets and immediately betrays interstellar origin. It passed just a little closer to the orbit of Mars to the Sun and never came dangerously close to Earth. There was no threat of a collision. Now, after perihelion, it's already moving away, but it's still active enough that large and even amateur telescopes can catch its tail and coma. One of the most striking recent news stories about 3I Atlas is the first radio observations of a comet. South Africa's Meerkat radio telescope recorded radio emission associated with this comet when it was particularly active. Social media, as usual, immediately erupted speculation. An interstellar object, strange behavior, now a radio signal in case it's an artificial probe. But the physics there is much more earthly, though no less interesting for that. The signal appeared at frequencies characteristic of the hydroxyl radicalon. It is formed when water ice in a comet evaporates and is destroyed by the sun's hard ultraviolet radiation. That is, the radio telescope literally hears the comet hiss-ping with water in the radio range. This is, firstly, direct confirmation that 3I Atlas does indeed have water and its chemistry is very similar to ordinary cometary processes. And secondly, it is the first such confident radio signal from an interstellar comet. This story of radio observations has become another argument against the alien ship scenario. We have a fairly standard explanation within physics and chemistry. But the controversy, of course, does not stop because a whole media image has now been built around interstellar objects. Anything that came not from here automatically gets the prefix alien in all the headlines. From here, the second hot topic grows smoothly. Real, whether it's a comet or something artificial. Avi Loeb, the same astrophysicist who once became famous for his bold hypothesis about the artificial nature of Oumuamua, is again actively involved in the discussion of 3I Atlas in interviews and podcasts. He draws attention to a few points. Unusual brightness at long distances, strange changes in brightness, possible slight non-gravitational accelerations, as if the object is slightly propped up by something other than gravity. Some authors even consider its trajectory in terms of optimality for a conditional reconnaissance probe that specifically adjusted its motion to the plane of the ecliptic to observe planets along the way. Against this background, there is a more relaxed position of the main part of the scientific community. Radio data, chemistry, and the behavior of the gas fit very well into the familiar pattern of cometary activity. The spectra of dust and gas are similar to what we see in comets coming to us from the outer regions of the solar system. Major reviews from professional observers and agencies are still unambiguous. 3I Atlas is considered a natural interstellar comet, although there are oddities in its behavior that have yet to be explained. So the official line is, yes, the object is unusual, but there's no conclusive evidence for an alien ship yet. But the media and YouTube, of course, are much more fond of the word alien and use any controversial point to make the headline louder. The fun begins when we look not just at the brightness, but at exactly how light reflects off the dust of the comet. This is where polarimetry comes into play, the measurement of the polarization of light. It helps to understand what size and shape dust particles are, whether they are smooth or porous, what they are roughly made of. One of the scientific teams conducted detailed polarimetric observations of 3I Atlas and found that its behavior is generally out of step with anything we've seen before. The comet had a very deep and narrow negative minimum of polarization at small phase angles and a rather specific angle at which the polarization changes sign. These parameters do not match with ordinary comets, asteroids, or even the previous interstellar object 2I Borisov. If Borisov was more like a supercomet in polarization, pronounced positive polarization, classic cometary behavior, then 3I Atlas shows a completely different character. In some ways, it more closely resembles strange bodies from the outer regions of our system, for example, individual trans-Neptunian objects or the Centaur Fall, which are covered with very dark mixtures of ice and complex organic matter. As a result, the researchers draw a cautious but very strong conclusion. 3I Atlas seems to be a new type of interstellar body that does not coincide in its optical properties with either the usual comets or previously known interstellar objects. This is almost a guarantee of scientific articles and long debates. Now to the tale. From the first pictures after opening, 3I Atlas really looked quite modest. A bit of dust, a bit of a coma. No dramatic tale like the classic comet shows. For an interstellar guest, people expected something more epic. But as we approached perihelion, the picture began to change. New images from both large telescopes and projects like the Virtual Telescope show that its ion tail has gradually stretched out, become longer and more complex. It stretches towards the opposite side of the sun, and there are noticeable heterogeneities in it, as if a comet ejects matter not smoothly, but in portions, in flashes. And here again questions arise. According to some researchers, in the area of maximum activity, the comet could have lost a fairly significant fraction of its mass, but for a long time it did not visually look as bright and corrosive as one might expect. This makes you wonder what kind of ice and materials it consists of, how they are mixed inside the core, how active zones are distributed on the surface. It is possible that there are areas of highly volatile ice in the 3I Atlas core that only turn on under certain conditions, and that part of the surface remains relatively stable and dark. A separate line is the story of observations from spacecraft off Mars. 3I Atlas orbited so well that it flew tens of millions of kilometers from the red planet and could be observed by several orbiting probes at once. This chance, of course, was seized. China's Tianwen-1 mission was one of the first to show the world images of an interstellar comet taken by a camera orbiting Mars. This footage shows a bright core and a huge coma stretching far into space. The American MRO with its famous high-rise camera also filmed 3I Atlas, but footage from the United States did not appear in the public domain for a long time. Against this backdrop, a small but high-profile media drama has unfolded, with China posting images, racking up likes and citations, and NASA being accused of being too closed, bureaucratic, and slow. The funding and shutdown situation in the United States has created additional strain, making many processes actually slower. It was easily mixed with lines like, "What are they hiding?" And this topic has also become part of the information field around the comet. But behind this visible picture race, there was a very serious scientific work going on in parallel. The European Orbiter Trace Gas Orbiter in orbit around Mars was used to make extremely accurate measurements of the comet's position against the background of stars. A pass near Mars provides an opportunity to bind the coordinates of an object very well. After processing this data, the scientists dramatically reduced the uncertainty in the 3I Atlas orbit. We know much more precisely where it came from and where it's going. These are not just numbers for a catalog. Such refined trajectories help in the future to search for a star system from which it may have been ejected billions of years ago, and to practice techniques in case we ever decide to launch special interceptor missions to such interstellar objects. If you look even deeper into its characteristics, it becomes interesting how it rotates and what color it looks like. Observations of the light curve showed that the rotation period of the core is about 16 hours. The amplitude of the brightness change is small but noticeable, hinting at an elongated, less than ideally spherical core. As the activity increases, the comet's color turns a little red, which coincides well with the behavior of comets coming from distant, cold regions like the Kuiper Belt. Calculations of the dust ejection rates showed that its initial activity was quite modest, a few kilograms of dust per second, while in some bright long-period comets this value can be orders of magnitude higher. And here comes one of the most interesting findings. Despite the fact that 3I Atlas came to us from another star system, it is remarkably similar in basic parameters to our distant comets. The water behaves similarly, the colors and overall evolution of activity resemble outer belt objects. Even the structure of the tail at some point becomes recognizable. This could mean that planetary systems elsewhere in the galaxy are building their cometary stocks out of very similar materials. That is, the conditions for the formation of ice and dust are not that different here and there. Or maybe it's that we still underestimate diversity, and 3I Atlas is just the first sign of a new class of objects that don't yet fit into our usual models. If you put everything that is now known into one picture, you get a portrait like this. 3I Atlas is definitely interstellar, which confirms its trajectory and speed. It has water and typical cometary chemistry, as confirmed by radio observations and spectral data. Its dust behaves extremely unusually in terms of polarization, hinting at an atypical composition or structure of the particles. The activity and tail didn't behave quite as expected. The change in evaporation modes was quite strange. A political media story unfolded around her, with photos from various space agencies and accusations of secrecy. And all this against the backdrop of the world of science still leaning toward the natural comet option, even as the boldest explorers continue to keep the door ajar for more exotic hypotheses. In a way, 3I Atlas is not just another dot on an astronomical map. It's a messenger from another star system that, for a very short time, gave us a glimpse into an alien planetary kitchen. We've heard its water sizzle in the radio range, seen its tail grow and break, and seen its dust behave strangely under the light of our sun. And even if it does not end up being an alien vehicle, it is already clear that thanks to it, we will have to refine and expand our understanding of what interstellar bodies are like. It will fly away forever, but the data we have time to collect over these months will be dissected by graphs, tables, and models for years to come. And for you and me, it's a rare chance to tell the audience a story about a real-life guest from other worlds, without fiction, but with so many mysteries that no screenwriter would be shy about it.